Okay, guys, so let me first show you the scene, okay? It's just a simple scene with a third person character, which has some animations, and then when you press G, you have different emotes that you can use. You see, so we'll discuss how to do this, but first of all, let me show you how to import characters and animations, okay? Because I think that's the first step.
Oh,
Yes, program?
I just said it was all right because you were saying stuff, and you said that you were gonna show us, so I said all right because you were gonna show us.
Okay. So let's
Didn't
start
mean
with
to interrupt.
how to add the character and then the animations. Okay. So I get these characters from a site called Mixamo. You can log in here with your Google. You can find free characters and then animations for those characters. Okay. So the first step is once you have a character, let's say we have this one here. The first step is you download. Excuse me. You download this character in T-pose. So you go here, download. Oh wait, that's me. My bad. I have to log in. One sec. I'm sorry. I was not logged in. Okay. So you have to download this in the FBX for Unity format in T-pose like this. So this is the character with the colors, the texture and the materials. And then you go here to animations and you can select and download animations from here. Let's say this one, but actually let me show you the running animation because if you get the running, you have to click this option here in place. So the animation does not move the character in world space, it stays in place. And then you download this FBX for Unity without skin because you already have the materials from that character in T-pose. And then this is how smooth the animation is, how many frames per second does it have. I like to get the best one, and that's it. Then you can download this. Okay. So once you download this, you just drag and drop those files in here. This is how they look like. And then this here is the T-pose character. So the first step is you have to extract the textures and the materials. You just go here, select the T-pose character, click extract textures, click OK, and then the materials as well. And then you have to create an avatar from this. So by default, this is not humanoid, this is something else. So you have to check humanoid here, animation type. And then you create from this model. And then click apply, and that will create this here, this avatar that you can use on the animations. So if you go to the animation, you can copy. Again, you set it to humanoid and then copy from other avatar. And here you place the avatar that you created from the character in T-pose. In here where it says source. After that, there are a couple of things. The first thing is if you want this animation to loop, you have to click this here, loop time, enable looping. And also for all animations, regardless of if they're looping or not, you have to click on this bake into pose. All of these three here, bake into pose. So that way, the animation does not affect the position or rotation of the character. It will not move it at all. And then once you have all of the animations, you set loop if it's necessary and root into pose. I mean, bake into pose here. You can drag them in the animator. This looks a bit complicated, but it's not that complicated. So you just drag and drop this here from the assets. And here the squares represent the animations, and the lines represent transitions from one animation to another. Okay. So to do these transitions, we use parameters here to create the condition. So for example, let's take this one, for example, from idle to walking. That happens when these conditions are true, if it is walking and if it's not running. Now these transitions can happen instantly or not. In this case, it happens instantly because you see here it says as exit time and it's not checked, so it will happen instantly. Also, there's a value here, this here. What this does is it blends this animation with the next one. So the more you the more you put in this here, if you increase this value, then the longer the blend is between the animations when you transition. Now, for the emotes, it's very simple because we just play that animation directly without transition. We just say play that specific animation. So you notice we just some of these have transitions back to idle, and those are the emotes that loop. The others one, I actually my bad. Those are the ones that do not loop. Those that loop do not need transition because we transition by script. So I want to show you now how to create this 3D third-person camera and the third-person controls. Okay, so let's there is a tutorial I sent you in the Discord, not made by me, it's made by someone else that I used for this. I'll try to make it simpler. I will just send you the scripts to do this, so you don't have to write them yourself. So let's start with the camera. So for the third-person camera, it's very simple. You just create, right-click, Cinemachine. Because actually, before I do this, you can make a script for this, but it's easier with the Cinemachine. So you go here, Cinemachine, create a Cinemachine camera. I already have it here, so this is the Cinemachine. And then you have to change two settings here. Here in position control, set it to orbiter follow, and then rotation control, rotation composer. So you change these two settings. Also, there will be here a button to add input system. You also have to click that. And then in my scene, I don't know why it wasn't working unless I change this priority. Yes, you should probably change the priority here. Check this box and then put a very large number here, like 100, like mine. And then what that will do is you have the third-person camera, but without the zoom in and out. So you just have this. For the zoom in and out, you have to make some code. Now by default, in the newer version of Unity, you have the new input system, which I don't understand very much. So what I recommend is you enable both the new one and the old one at the same time. So you go here to project settings, in the player settings here, and then other settings. And here it says somewhere, yeah, here, active input handling. You should select both, so you can use both the new one and the old one. This will reset the project. It will restart. Now for the zoom in and out, you can follow that tutorial, but if you don't want to do that, I'll show you. I'll just send you the script for this. Now, but the first thing you need to do is you have this this input action asset. By default, it's not this name. I renamed it player control. So you should search for input in the search bar and find this, and then rename it to player controls. And then in here, this is from the tutorial. You have to create an action map here. So I already have it. You call it camera controls. Then this is the action mouse zoom. You should change the name to mouse zoom. Now on the right here, you change the action type to value and control type vector 2, okay? And then here, this is the binding. You change it to scroll mouse. And then save it, and also go here in the imports in the inspector and generate the C# class. So you click this and then apply, and this will create a script that we'll use for the zoom in. So the zoom will be on the Cinemachine camera. It's a script. So if you do that and just put this script that I will send you on the Cinemachine camera, you should have zoom in and out. If you don't, if that was too quick, you can look at that tutorial. Now let's discuss the movement. Let me open the script. And while it's opening, let me explain you the idea. Oh, actually, it opens very fast. Okay. And please, if you have questions, stop me at any point. So the way it works is we move the forward, backwards, right, left, and right are relative to the camera. Let me see. Relative to the camera, right? But the issue is the camera, sometimes the forward of the camera, because we rotate it in 3D, sometimes it looks towards the ground and sometimes looks towards the sky, and we don't want that. We want the forward of the camera to be parallel to the forward of the player. So in simpler words, it should not look down or up. So what I did is I created an empty object that will have the rotation of the camera, but the forward will be parallel to the ground. So if you look at this script here, we have the transform of the camera here, and every frame we change the rotation to that rotation that the camera has, but on the X we keep 0. So that way the forward is parallel to the ground. Okay. Let's look at the player script. We get the input with the horizontal and vertical axis, not with keys, because this is a bit better. So again, this here, for example, it's either -1, 0, or 1. It's -1 when you move to the left, it's 1 when you move to the right, and it's 0 when you press nothing. Same for the vertical axis, but that's for forward and backward movement. So what we do here, we say if we are moving, so if either that horizontal axis or vertical axis is different than 0, so if you're moving, we disable, we make the easy mode parameter in the animator. This will disable the emotes if we are in an emote. Then we say we're walking because we're moving. And these two lines here, rotate the player in the direction in which he's moving. So what I do here is, this can be done in many ways, but what I do here is I create a point in space in front of the player, and then I look at it. So this will rotate it to look towards that point. Okay. So that point will be, let's see, the position of the player right now, plus the forward times the vertical axis. So, for example, let's say we're moving just to the right. Okay, we're moving to the right. So this will be 0, obviously, because this vertical axis will be 0 because we're not moving forward. So we can ignore this. This is nothing. This is nothing. And then this will be the right relative to the camera, and then times this will represent the direction in which you're moving horizontally. So that's the idea here. I hope you understand. If you don't understand, let me know. So else meaning, I should actually comment this. Let me comment this. So here is means if are moving. I should comment this. My bad, I forgot to comment it. So if we're moving, we do this. If we're not moving, we just disable the animation by setting that parameter to false, so we're no longer walking. Now on shift, we transition from walking to running. Okay, so input get key down means whatever you put inside will happen once when you press the key, when the key is pressed down. And then you can say key code and put whatever key you want. So when we press down, we get we enable running animation here with the parameter, and then we change the move speed to run speed. And when we release it, we disable the run speed and return to walking speed. For jumping, we only can jump if we're not already jumping at this moment. So we check if we're jumping. If we're not jumping, in that case, we check for spacebar. We say now we're jumping. We enable the jump animation, and we add jump force. So the velocity will be now of the rigid body will be the same, but on the Y we change it to jump force. So we maintain the forward and left-right movement, but on the Y we change the velocity to jump force. And then on G we spawn that UI to select any mode. Okay. But not really. Actually, what we do here is we enable it only if it's not already enabled. And also we say cursor lock state. Here we enable the mouse because the mouse is not active by default. Now for the movement, when we move the player with the rigid body, when we update the speed, okay, we create a vector tree that will be the velocity. Let me see. Yes, so we take the forward relative to the camera times the vertical axis. So this, wait, what am I doing here? Oh, okay, my bad. Okay. So this part here in parentheses is the direction. This will represent the direction in which you're moving. So you have the forward of the camera times the vertical axis. So that's the forward of the camera, and this will represent the direction. So if it's negative, this will move backwards. If it's positive, it's forward. Plus the right relative to the camera times the horizontal axis. So the same, but for horizontal movement. And then we take the direction and multiply it by our move speed, which is just a float. But if we just use this, the y of this vector 3 will be 0. So if we're jumping, this will freeze the object in the air because the velocity, because the y is 0. So the movement speed vertically is 0. So what we do is we take this vector 3, change the y to the y that the rigid body has right now. So that way we maintain movement vertically. And then we update the velocity here to the vector 3 that we created. Okay. And if you update the velocity every frame, you have to do it in fixed update. Otherwise, there is a delay. I'm not sure exactly how this works. So what do you guys think? Is this useful for you? Please use the chat if you want of this voice chat. Are you guys?
I'd say it is useful. I just don't really understand Unity that much, so it's like it's not extremely useful, but still useful once I do learn Unity.
Okay, so would you like me to be to explain a bit more in detail when I look at the
No,
code?
it's fine.
Okay.
It's just
Okay. Let's see. Okay, let me explain how this UI works. So for UI, okay, I'll try to explain more in detail, okay? Because I see you're a beginner, okay? So for UI elements, we use canvas, the canvas. So you just right click here, UI, and create a canvas to where then you can put elements in that canvas, UI elements. Now by default is overlay, so this will be on top of everything. So for stuff like settings in a menu, the health bar, I don't know, stuff like that. Maybe aircraft, stuff like that. Now this can also be in world space, so that way it will behave like a 3D object. It will be in world space. All the UI elements that you put in it will behave as 3D objects. But for this we use overlay, and then by default this is constant pixel size. You always change it to scale with screen size, so that this way the UI elements will stretch with the screen the resolution. And here I put full HD usually. Uh, uh, so I just have a holder here, an empty object that will hold this button. So if I change this here in the scene to 2D, we can see here the canvas, and I positioned this manually. Um, and initially I was thinking of making an animation, but I discovered that you cannot change the position with animation system. I don't know why. So we don't have an animation. Now you notice that this holder, represented by the square here, has these things in the corner. Okay, these are called anchors. So by putting them like this object will always be there and will always have this size. It will stretch with the screen resolution. So for the buttons, we have a script on each button. So in that script, this is a very simple script. We just save two things: the animator of the player, so we can enable that animation, a specific animation, and the name of the animation. Okay, and then we have a public function. So that way we can put this on the button when we click it. It needs to be public, otherwise you cannot see it when you try to add it to the button. So the first thing we do is, because we close this UI and start animation, we block the mouse, so we cannot no longer see the mouse, the cursor. And then here we set up the bool to is emote to true, so that way we know we're in a emote. And we play that specific animation. So we say animator play in the name of the animation that we have in a variable. And then we disable the UI with this. So that's how this works. And we get out of the animation, like I said, in two ways. One is it simply ends because it's not loopable, but if it's loopable, when we move, it stops. So that's the idea. Let me see if there's anything else I can show you. I have two more examples for you. One is an example where you throw a hook to grab stuff. It's not the greatest. Let's start with the fishing. Made a fishing example.
I have to go do something really quick. I'll be back in like 5 minutes. So
Okay.
yeah.
Okay. I'll wait. No problem. Let me know when you're back.
All right, I'm back.
Let me show the example first. It's the controls are exactly the same for this, but I have this fishing animation here, and then you have a little mini game when you fish. So you see, you have to press this in this order that's shown. Okay, you see, and then that stops the. And if you press it incorrectly, it says fail. Now there's only one issue, which is you can fish anywhere, not just near the water. Let's look at how this works. Okay, we'll not discuss the uh, movement because it's exactly the same as the previous scene. But let me show you how I made this puzzle. So let's go to the canvas first. So I have this. This is just an empty object that holds this. Then we have the background, the black rectangle, and on top of that there are buttons. And I use horizontal layout group, so that way these are at equal distance from each other. One second, I have a script. This will be a bit more advanced. I'm sorry, in advance. One second. So these buttons here, if I'm not mistaken, yes, they have a script here. One second. So we have I will go in detail in this because this is very useful to know. So this is a script on the button. We have a bool here that lets us know if you can interact with that button. Okay, by default false, because when we start this puzzle, we show the sequence, the correct sequence, and until that is finished, we cannot interact with this button. Also, the button has an index, so we know which button this is. It's just an integer. And then all buttons are connected to the fishing script here. So we have a coroutine that creates that effect when we fade the color in and out. This is the most important part because you can use this for many things, not just color. You can change any value over time with this. So in this case, we have a starting alpha. Alpha means transparency. So we start from starting, we have the end alpha 1. The 1 means fully visible. 0 means invisible. 0.3 is just the default that UI has when the puzzle starts. So here we fade in. The fade out is the same. So let's look at the fade in. We have here, we have a float instead of an integer in a for loop. So we start from 0 to 1. And then each frame, each time we go through this, we add the time difference between frames. So that means, in other words, we count time in seconds in this t. So if you just consider this part here, that means this will last 1 second. But we want this to last a specific amount of seconds, so we divide by fade duration. So that way, this here will last this amount of seconds, the fade duration variable. And then every frame we update the color here. So you say the image color, the color of the button is equal to color, And you see we maintain the red, green, and blue here. We maintain the color. We just change the alpha at the end with this matfleur. So what this is here is selects a value between a starting point and an ending point by this third parameter here. So for example, if this t here is 0, then we're at the starting value. This will return the starting value. If this is 1 at the end, the t, then we are at the ending value. And if it's 0.5, for example, it's exactly in the middle. So that's how this works. We go from a starting value to an ending value. And then here we have this line of code because this is not always the exact end value. So here we make sure it's the end value exactly. So we fade in, and the same logic we fade out that color, the transparency of the color of the button. So and also yield return null here means wait one visual frame. That's what this means. So each time we go to this, we wait one visual frame. So we have this effect. We also have a on-click button function. So if we can interact, but before we look at this, let's look at how we create the correct sequence of colors. Okay. For that we have a list. We have a list, an integer list with the indexes of the correct colors. So that this will be the sequence, the correct sequence for the puzzle. We also have an integer number clicked buttons. So when we start the puzzle, we start from this will be 0, and with this we know how many buttons we clicked correctly with this variable. So you see here by default it's 0, and on enable, because we enable and disable that UI, on enable we set it to 0 because we start the puzzle when we enable it. So we start from 0, correctly clicked buttons. And here we rearrange those buttons. So always there is a random arrangement of those buttons. And by random arrangement, I mean in this horizontal layout group. One sec. It's loading. I don't know. So let me show you what I mean by repositioning. So you see, wait, I have a. Oh yeah, my inspector is bugged. I'm sorry. We'll have to restart this. I'm sorry. But the idea is, you see, if I move this down, it's rearranged. You see, it moves, visually moves. So that's what I do in this script. So what I do is I select it. I go from 0, the number of buttons that I have, and then each button I put it in a random position in I mean the sibling index. So I rearrange them, and then I have to create that array. So the correct sequence. I have a coroutine for that because this takes time, because we do that fade, the transparency fade on each button. So that takes time. So I have to use a coroutine for this. So we wait some time before we start creating and showing that sequence. Well, we visually showed the sequence here. Let's see. This is the number of colors. So how many colors we have? And then we make that list of that represent the sequence. We create a new list, an empty list. So there's nothing in this list. There are no elements. And then we go from 0 to the number of colors, and we create a random color here. We show a random color. So we create a random index. So to select a random button, we add the index of that button to our sequence. We fade it, so we show that this is the button. We show that little animation, and we wait for the animation to finish, and then we wait some time between the buttons. So we have enough time to see the sequence and remember it. And then we make all buttons interactable. So now we can click those buttons. Okay. And then we have a function for clicking buttons. This is we went back to the button script. So now because it is interactable, we can click it, and when we click, we fade the transparency. And now we check if this button has the correct index here. So if it's the same as the one in the array, that represents the correct sequence. So if it is correct, we say then that number buttons plus plus. So we click correctly one button. And then here we check if we reach the maximum number of correct buttons. So in other words, if you finish the puzzle correctly. In that case, we just change that text to success and stop fishing. We have method for stopping the fishing. And else, if we fail, we just say fail and we stop fishing as well. That's it here. When we stop fishing, we just disable the UI, disable the animation, disable the fishing pole, and that's it. That's how this works. Now I want to show you something that's useful. One sec. I'm getting an error. I'm sorry. One sec. My inspector, yeah, my inspector is bugged for some reason. I don't know why my inspector is bugged. But I wanted to explain that the fishing rod is attached as child of the hand of the guy. Okay, that's what I wanted to show you. Unfortunately, I'll have to close this and open the next project because I have a problem with the inspector. I'll show you two more examples and that will be everything. If you have questions, please write them in the chat. We can also discuss after we finish. We can discuss whatever you want. So I have a problem with that project. I don't know why the inspector gets bugged. I showed you the one with the emotes, the one with the fishing. This is the one with throwing a hook and grabbing stuff. So we have controls the same, but when you press F, or not F, what? You see, we have this effect. You can drag stuff, but I don't know what happens with the. It disappears for some reason. Don't know what that is. Okay, I guess I have to look at this because it's not correct. It works correctly until it reaches the end. Let's see why that is. But let me explain the idea here. I'll just explain the idea. We will not look at the code because it's a bit complicated. So the idea is we have we know the exact point of the finger here when you have this animation, and we start the hook from there, then the forward of the camera actually, or not the camera. I think the character. So the idea is we spawn these parts of the chain. Okay, so let me show you what I mean by that. So you see we have this here, these parts of the chain. So we spawn this. We have the part of the chain without a collider, and at the end we have a part that has a collider, so you can collide with the object that we're trying to grab. So the idea is we have this end, chain end, with a collider at the end, and then we move it forward by a specific amount, and after that we spawn this one without the uh, collider behind the end of the chain, and we keep doing this for a certain amount of times. Um, and then when the hook touches the object, that object that becomes a child of the end of the chain, and then we just move the end of the chain backwards and we delete those chains, those parts one by one as it's going backwards towards the character. So that's how this works, but for some reason it disappears when it reaches the end. So let's see why that happens. I'm curious why that happens, and then we can look at another example, which is which you will understand much better because it's a bit much simpler than this. Um, so let's see the script. I don't know. This is not supposed to happen, but that's the idea. That's the idea. Again, we have the end of the chain. We throw that. We spawn parts behind that as it's moving forward, and when it reaches the target becomes child of the end. Then it moves backwards and deletes the part that is going backwards, and then when it reaches the when it appears completely, the object that we grabbed no longer has that parent that is the end of the chain. So that's how that works. I'll show one more, and then um, you can ask questions, and if you have suggestions for what examples I should make, please let me know. Now that I'm looking at this, I should make some simpler examples. Should probably look at some Unity functions maybe in the future. Okay, here I will show you some stuff. So first of all, let me show you how to change a skybox in Unity. So I have this space skybox here. So how do you download it first? Once you went to the Unity Asset Store. So let me show you actually the Unity Asset Store. You go here, you log in, and then you have to search for Skybox. And you can change the price to free. And these are the options. Let's say want this one here. You just add it to assets here. You click this button, and then you can open it. Wait, I don't know what happened there. So you just add it to your assets, and from here you can also, yeah, it's not working. I don't know why. Why is my assets so not working? So you click this button, and then you can also open in Unity from here. But if you want, if you don't open it from here, you can go to Package Manager here, Package Management. Then you go to My Assets here and search for your skybox asset here. And then you just download and then click Import and click OK, and then you have your assets. You have your skybox here in the assets. Then how do you apply it? Go to Window, Rendering Lighting, Environment here, and you see skybox material. You place your skybox material here. That's how you change it. Now I also use the ProBuilder from Unity, which lets you make shapes. It works well with materials that you download from the Unity Assets Store. I'll show you in a second what I mean by that. So let's see how to actually 3D. 1 second. I'm trying to find the ProBuilder here. Yes, here it is. So you right click on the in the hierarchy, and then you go to ProBuilder here. You can create shapes with this. And then you don't change it, you don't change the scale, you change the ProBuilder shape here. It says, unlike the normal cube, you see this has a pattern. And then you can place materials on this, and it looks better than the default. And I'll show you what I mean by that. Let's find the material first. Let's say we want the brick here. You see, but it's a bit too much. Cannot see the pattern very well. So what you can do in this situation, you select the material, and then in tiling here, you decrease it. So let's say you put 0.2, and you see now it repeats less amount of times, and you can see it. So to change that again, you go to the material and change the tiling, make it smaller. Okay, so this is a scene where we have this cube. We have a platform that's made with ProBuilder and the material cube as well, and then you can just move it like this. Let me show. You see. So, and it doesn't go over the edge. That's the idea. I actually want to add more stuff to this, like walls and movable objects. And if you have time, we can actually do it now if you want. But let me show you this, because this is much simpler than what I showed you previously. And let me know if you want. If you have time, we can add walls to this and movable objects if you have time for that. I can. It actually would be more helpful because you can see the process. I don't fully understand the rotation because I did it with ChatGPT. Not sure how the rotation works exactly, but I'll try my best to explain. So for this, it's very simple. We have a bool to know if you're moving, and the reason is we use a coroutine to move the object over time, and we don't want to overlap this coroutine. So only do it if we're not moving. So with this, we know if we're moving. We have a move duration. So how fast do we move from how fast we move by 1 unit. Move direction, this will represent the direction in which we're moving. In update, we check for input here, but we only do it if we're not moving. So we only move if we're not moving. And then if we're not moving, we check for input. So if it's A, that means we're moving to the left. So we set the direction to left, and then we start that coroutine that moves the cube. The same for the other keys, W, D, and S. The only thing that differs here is the direction which we're moving. And then the coroutine that moves it, not that complicated. At the start we say we're moving, so it's moving is true. Then we say this is the actually let me see what it is. One second, I don't know why this is here. This should not be here. I literally have a variable here that I'm not using. Okay, so I'll just comment. So this is not supposed to be here. Okay. So what we do is we need to raycast in the direction in which we're moving for two reasons. One is we need to know if there's a wall or a movable object in front of us. So that's the first thing that we do here. You see, we raycast, and again, if you don't know what raycast is we create a collider in the shape of a line, and we use it to detect stuff. This exists for one frame. Create a collider in the shape of a line for one frame to see if there's something. So you can imagine it as a ray of light that's going forward and stopped as the first things that hits. So that's what we do here. We raycast in the direction in which we're moving, and we see if there is an object there. So if there is no object, then we raycast again from the next square in the direction in which you are moving below. So that way, with this, we know if we are on the if the square where we want to move, if below of the square where we want to move, if there is a platform there. So in other words, if we're not going over the edge of the platform, that's why we raycast at the next at the position where we want to move below. So we know it is if we are at the edge. If we're not at the edge, so if you hit something doing this, it means we will be on the platform when we move. And then here we have a starting position and an ending position. So the starting position is the position right now, transform position. The end position is the position right now plus the move direction. Because we only move by one unit and we don't have to multiply this by anything. And then this is some stuff that I'm not sure how it works for the rotation. Let's see. Yes, we have to decide here the rotate axis. So we use my bad, I know what this means, I'm sorry. So we rotate it with the transform rotate function. This rotates the object by a vector 3. So we here, depending on the direction in which you're moving, we select an axis to rotate the cube around. So here we select the axis to rotate the cube around, and also we save the initial rotation. So that will be transformed at Euler angles, the rotation right now, before we rotate it. And then this for loop, like I showed you before, we move the cube over time, and we rotate it over time here. Don't ask me how this works, I'm not sure, but the idea is this will try to rotate it almost 90 degrees in the direction in which is moving. It's not perfect. So then after this, we have to rotate it perfectly. And I was thinking of something very complicated when I first did this, but I found a simpler solution, which is we rotate this to the starting rotation, the rotation that it had before before we rotated it, and then we rotate it on the same axis by 90 degrees. So that way we make sure it's rotated exactly 90 degrees. And also the position here at the end, we make sure it's the exact end value, because sometimes with this is almost exactly, but not exactly. And then I have some lines here that should not be here. Also this here, let me do that. So that's it. That's how this. And at the end we say is moving is false, so we can again move it in the when we get the input. So that's everything I prepared for today. If you have questions or suggestions, we can add stuff to this right now if you want. Please let me know.
Yeah, I have no questions.
Okay. Do you have suggestions for examples, or maybe you want, if you want, we can continue this example here. You can add walls and movable objects. Yeah. If not, then
No, no thanks, but thank you for everything.
yeah, sure.
I'm gonna go now.
Okay. Okay. Thank you
Bye.
very much. I'll see you.